Our introduction to the in-suit treatment of hazardous soil. Um, Biological treatment, chemical oxidization, permeable treatment bed, soil flushing, vapor extraction. This publication is adapted to Unified Facility Government Criteria, United States Government, which are public domain, authorized and limited distribution, and not copyrighted. All right, biological treatment process description. Organic materials and contaminated soil may be amendable to biodegradation in place into process consistently. Larger producing condition soil mass promote the rate of natural degradation. Endogenous organism condition favoring biodegradation include increased aeration, nutrient concentration. Some cases of seed culturals may increase active population beneficial. 112 biodegradation processes. Slow, relatively other relevant remedial action technology. Completely degradation of the waste could be take several years or may never complete if the refractory compounds such as poly or nuclear aromatics are present. The major disadvantage some additional mitigation contaminants can occur during treatment in earth even afterwards. 113. The technique is generally limited to those situations waste of material contaminated soil is naturally aerated where artificial aeration is feasible. Procedures additional nutrients such as nitrogen, phosphorus may be necessary in waste materials and deficiency within this constitution. Lime may be required to maintain proper pH. 1-2 applications situations where soup bioremediation can be applied with those for the complete with the mixing aeration can be achieved. Primary application chemical spill land spreading operation where wastes are not mitigated tilting depth of 12 to 24 inches surface impoundment in which the waste is fluid enough to mechanically aerated and pumping with the mix. Biodegradation has been used most widely treatment with the oily sludge of refinery waste, chlorinated solvents such as the TCE and PCE are not degraded efficiently with the use of the current technology. However, the work is continually these materials naturally occurring bacteria special cultures have developed which are capable of degrading benzene, phenol, cresio, naphthalene, gasoline, kerosene, and cyanide, and many of the other derivatives. 1-3 advantages and disadvantages. Inland treatment soils are not well aerated. Water degradation will occur only slowly because the metals are not degraded. But the careful attention should be given with a toxic metal load at the site. Since the process can be very slow, adding mitigation with the contaminants may take place during and after treatment. Also, a possibility of forming toxic product result of biodegradation should be considered. Data requirements: the type of the quantity distribution, waste constitutes have to be determined to select nutrient requirements. Tests must be made to determine the microorganism naturally occurring, which will break down the target chemicals. If not present, enriching seed culture may be required. 1. The site topographical, hydrology, and soil physical, chemical, and biological mechanical properties are necessary to determine the injection withdrawal and system requirements design. 1.5 Design criteria. The key factor of the degradation include nutrient balance, pH maintenance, soil aeration, oxygen availability, degradation rate of waste, constitute weight, constitute location. 2. Chemical oxidization. Process description. In-suit Lechat treatment introduces reactant with the contaminated region and interact with the Lechat plum. Chemical injection entails injecting chemicals into the ground beneath the waste to neutralize, precipitate, and destroy Lechat constitutes of the concern. Application: some hydrochlorate may be used to treat Lechat containing cyanide. Very little field data is available. Aerial spread and depth of Lechat plume must also be characterized so the injection wells can be placed properly to intercept all contaminated groundwater. Advantages: pollutants must be displaced if the adjacent where the chemical solution is added. Hazardous compounds may be produced by reaction interjected chemical solution. Waste constitutes other than treatment for target. Data requirements. Principal data requirements include the contamination plume characteristic, depth, bedrock, plume cross section, Lechat, or groundwater velocity, hydraulic gradient, as also soil permeable Lechat composition reaction rates, which will be determined. Design criteria: chemical injection system, conceptual stage development, permeable soil beneath the waste must now determine groundwater flow through the injected waste and reaction time between contaminated groundwater and chemicals. Shows the water table 120 feet, 20 feet, 20 by 90 feet, metering pipe, hydraulic storage, well pump, 4 header acres or 10 acres stream, refuse injection pump and chemicals injection successful, water supply, bedrock unconcentrated earth not to scale. Alright, 3. Permeable treatment beds. The process description. Permeable treatment beds are trench fills with receiving reactive permeable medium into the underground reactor. Figure 429. Contaminated groundwater last yet entering bedrocks that produce non-hazardous soluble products participate. Applications. Permeable treatment beds are applicable to relatively shallow aquifers since trenches may be constructed due to the level of the bedrock and permeable clay. Permeable treatment beds are often effective on short time as they may be lost capacity, become pledged with soil over design of the system. Placement permeable medium for the length and time of the period over the permeable treatment effective. The material is used for the form of the treatment are limestone crushed shell, limestone neutralized acid groundwater, may remove heavy metals such as CDFR, cadonium, ferrite, and chromium. Dielectric limestone is less effective at removing the heavy metal with the calcium carbonate limestone. Particular side of the limestone should match. Mixing the gravel and sand side, large size, minimized setting of the bed, and channeling limestone dissolves. Small size maximum content explorated bench scale indicated the contact time needed to change one pH unit in 8 to 15 days. Shows the water table, the groundwater flow, the bedrock, the stream, the permeable treatment bed, the refuse. Activated carbon. Activated carbon removes non-polar organic contaminants of the sea, carbon chlorides and bichlorine biethanols, lethenzine, and by absorption. Activated carbon must be wetted sieved prior to installation effective of surface solution contact. Galvanic green sand. Sand is actually granite clay. Is found predominantly in the coastal plain mid-Atlantic states. Having good capacity absorbing heavy metals. Bench scale studies include removal efficiency greater than 90%. The ASC copper 60 89%, and then detention times over several days. Zeolites and synthetic ion exchange resin of these materials are also effective in removing stabilized heavy metals. Disadvantage such short life, high cost, regeneration difficulties of the material, economically unattractive use, permeable treatment beds. Disadvantages: plugging in the bed may divert contaminated groundwater and channeling through the bed may occur. Both problems permit passage of untreated waste. Channel hydraulic loads and contaminant levels may render detention inadequate to achieve design removal. Data requirements. Principal data requirements include contamination plume characteristics, depth of the bedrock, plume cross-section, lashette, groundwater velocity, hydraulic gradient, arsal soil, permanent lashette, composition reaction rates at which they have to be determined. 3.5 Design criteria. Permeable treatment bed is constructed in design trench and impermeable layer bedrock or clay, filling the trench with appropriate material and capping the controlled infiltration. The width of the trench is determined by permeable of the material treatment and with the groundwater flow, velocity, contact time required treatment. These parameters are barrier width equals the groundwater flow velocity barrier in microseconds times constant time to achieve the desired removal in seconds, and the groundwater velocity v is in turn determined by Darcy's law. V equals Ks, where the gradient loss of head per unit in the direction of flow is times the coefficient permeable soil specific value maximum second is equal to groundwater velocity. Alright, since the groundwater velocity through permeable bed rock, permeable bed cannot determine the trench design, maximum groundwater velocity through the soil assumes one of the hydrogen gradient is equal to the soil of the permeable bed. Permeable barrier must be equal to that of the soil. 4. Soil flushing. Alright, the process description. Soil mining and extraction with the application solid of the waste solid sludge collection alliterate all points for the removal of the treatment of the hazard waste consists due to the type of solvent due to the water, acid, sulfuric acid, nitric, phosphorus, carbon, ammonia, and or chelating agents of the such as the EDTA with soluble heavy metal with either organic or inorganic ions. Solvent and collective fraction can be replaced through landfill, which make up the solution, remain treated and disposed. Application: chemical extraction have been used in the chemical process in mining industry for many years. The techniques are well understood and the experience with the Situ treatment as waste lacking, therefore very little data available. Application technology, remedial action setting, bench scale laboratory studies, extraction of heavy metal with sludge and plans to conduct full scale metal extraction industrial waste have been made. Advantages and disadvantages. Advantage of the process as for the waste is an amendable technique. Distribution, collection, treatment costs very low, relatively low solution. Mining present economical alternative excavation treatment of waste, in particular applicable to high safety health standards associated with the excavation. Also effective is completion of the treatment process. Measure V of the sample prior to waste treatment. Disadvantages use and uncertainty respect adequate contact waste because of the waste or burn. Buried. Determine whether the solvent contaminated all waste. All containerized waste can be treated with effectively by this method. Another disadvantage in solution may be solvent. Obliterate may become pollutant itself if the system has been poorly designed. Data requirements. Principal data requirements include laboratory testing, determining extraction efficiency, solvent waste analysis, present constitute non-compatible with the solvent, all field testing of geological hydraulic site survey, establish potential and solvent mitigation to uncontaminated groundwater to establish placement site with the collection of the eluded required. Sign requirement of data required to determine the selection and extraction of solvent the well placement of the collection of laterite and injection well location and extracting solvent. Alright, 5. Vapor extraction. Background. Soil must be contaminated with a number of the waste of the volatile organic chemicals, include industrial solvent, gasoline components, source contaminants near the extra air surface with the intentional disposal, leaking underground storage, accidental spills, contaminated groundwater through the course of the contain even an event of discharge, stop because of the unsaturated zone of the groundwater aquifer, retain a portion of all contaminated discharge, rain, influence, chemical eluted with the contaminated soil migrated toward groundwater. Process description. A soil vapor extraction force air ventilating into stripping system revolves around the extraction air containing volatile chemicals from unsaturated soil. Fresh air injected with the lows of the soil surface to all the locations, spill site, vapor laden and withdrawal of the under vacuum for recovery of the extraction wells. Alright, show 4.3 shows soil vapor extraction system. Inlet well, extraction well, air, water, separated contaminated soil, groundwater table cap, boiler, and vapor treatment. And the simple as soil vapor extraction system, air flows the extraction well with the ground surface to enhance the airflow with the zone with the maximum contamination. Maybe desirable to include the air well inlet wells into the installation. These injection wells and air vents whose function is to control the air into the contaminated zone may be located in numerous places around the site. Typically, injection wells, air vents, constructed similar to extraction wells. In some installation, extraction wells have been designed so they can be used as air inlets. Usually, only a fraction extracted air comes from the air inlets. That indicates the air from the surface is the predominant source of clean air. Extraction wells are typically designed to fully penetrate unsaturated zone capillary fringe. Extraction wells usually consist of slotted plastic pipe placed in permeable packing sealed near the surface to avoid short circuiting. During remediation, the blower is turned on and the airflow through the soil will come to equilibrium flows are finally established by a functioning equipment, the full control device, geometrical well layout, and site characteristics, air permeability of the soil, end of the operation, the final distribution of VOC site may be measured in decontamination of the site wells, may be aligned with vertical, horizontal, vertical alignment, typically deeper to contaminating zone residual radial flow parameters, and the depth of contaminated soil or depth of groundwater table less than 10 to 15 feet. It may become practical to dig a trench cross action contaminant, install horizontal perforated piping and trench pump bottom rather than install the vertical extraction well. Use several wells are installed at a time. Alright, the means to verify the success, cleanup of the often problematic soil sampling, difficulty because of the uncertainties, reciprocating of the sampling, and action measuring soil gas concentration are more repeatable but difficult to relate the regular standards where they exist. The applications, alternative decontamination, unsaturated soil include excavation, on-site, off-site treatment, disposal, biological degradation, soil flushing, soil vapor extraction. It is accepted cost-effective technique to remove organic compounds of contaminated soil. Soil vapor extraction can be efficiently used for removing a wide range of volatile chemicals in a wide range of conditions. Designing operation of these systems is flexible to allow the rapid change of operation, thus removal of chemicals. Advantages and disadvantages. Advantages and disadvantages of soil vapor actions are summarized below. And data requirements, a number of variable characteristics of successful design and operation of vapor extraction systems. Site conditions, distribution of VOC to depth of the groundwater, infiltration rate, location of heterogeneities, include paved and sealed areas, temperature, atmospheric pressure, soil properties, permanent porous, organic carbon content, soil structure, soil moisture, characters, particle size, distribution, controllable variables, all air withdrawal rate with well configuration, extraction well spacing, wet well spacing, ground surface covering, inlet VOC concentration, moisture content, and pumping duration. Responsible variables, pressure gradient, final distribution of VOCs, final moisture content, extracted air concentration, extracted air temperature, extracted air moisture and power usage, chemical properties, Henry's constant, soluble absorption, equilibrium, diffusivity, air and water density and viscosity. Design criteria: design and operational soil vapor extract system can be quite flexible, changing maybe the course of the operation with regard to well placement and blower size, airflows in individual wells. If the system is not operating efficiently, change the well placement and capping of the surface may be improved based on the current state of the technology. Soil vapor extraction system. The following designs can be recommended: intermittent blow operation, probably more efficient in the terms of removing the most chemical with the least energy. Extraction wells are usually screened with a depth of 1.5 to 3 meters or 5 to 10 feet below the surface of the groundwater. The able thickness zone of the unsaturated soil, maximum screen lengths of 20 to 30 feet of area are specified. Air water separators assembled construction should be properly installed at every system. Install a cap over the areas to vent to reduce the chance of the extracting wells water extending the path of the airflow over the ground surface of the rear by increasing the volume of soil treated. Incremental installation wells, although probably more expensive, allow for the greater degree of the freedom. Design module construction where the most contaminated zones are vented first, preferably. Use soil vapor probes, conjunction with soil borings to assess for final cleanup. Less expensive than soil bearings alone. Usually a complete material balance, given the site impossible must make. Most sites have an unknown amount of VOC in the soil and groundwater. Soil vapor extraction systems are usually only part of a system or remediational system. Although a number of the variables in issue the active rate of chemical extraction, no extensive study to correlate the variable to extraction rate has been identified. Well spacing, usually based on some estimate of the radius influence of the individual extraction well. Well spacing has ranged from 15 to 100 feet. Well spacing should decrease the soil bulk density, increase the porosity of the soil, decrease. One of the major differences noted between the soil system with soil boring diameter. Large boring is preferred to minimize extraction of liquid water from the soil. Wells should be constructed with approximately 20 feet over the bank casing with the top of the screened soil surface to prevent short circuiting of air or to attract deep contamination. Initial VOC recovery rates are relatively high. They decrease as systematically with 2-0 with time. Several studies indicate that intermittent venting of the individual wells is probably more than efficient in terms of mass VOC extracted per unit of energy expended, usually especially true when extracting soil where mass transfer is limited diffusion of out in mobile water. Optimal operation of soil vapor extraction system may involve taking individual wells in and out to allow liquid diffusion to change airflow patterns in the region being vented. Air injection has the advantage of controlling air movement, but injection systems need to be carefully designed. And then it goes into the quiz, and that was a quick read through on introduction into treatment of hazardous soils. Testing.